The purpose of this project is to determine the reliability of a PDMS-casted incubator for use in a mobile-based ELISA kit, as well as to investigate a promising feedback method for augmenting the incubation period. ELISA, which stands for Enzyme-Linked Immunoassorbent Assay, sometimes known as EIA, is a technique used to detect and quantify various biochemicals and complex mixtures through highly specific antibody interactions. EIAs are performed by initially immobilizing the compound of interest to the plate surface. The immobilized compound is then complexed with an enzyme-linked antibody. The enzyme complex is incubated in the presence of a substrate in order to produce a measurable product. The measured product is used to determine the conjugated enzyme activity and thusly to quantify the compound of interest, in this case by colorimetric analysis. However, most commercial ELISA kits are bulky, expensive, and often absent from point of care, which in turn limits the availability of fast and accurate measurements of important biochemical indicators of health and disease. Luckily, IBIS Lab has designed a cheaper, more compact, mobile-based ELISA system to combat these limitations by taking advantage of the ever-growing availability of mobile phones, plastic 3D printed parts, and simple electronic components. Looking back on the incubation period of an EIA, care must be given to avoid both overheating the sample, as excess heat will denature complex biochemicals, as well as underheating the sample, as this would fail to accurately measure the activity of the conjugated enzyme. The incubator used in the current mobile ELISA kit is constructed by first winding copper wire around the upper mold pegs. The mold is layered with tape for ease of removal and the adapter fixed to the slot by hot glue. The mold is assembled and the PDMS, after removing air bubbles, is poured to fill. The mold is heat treated at 75 degrees Celsius for about an hour to avoid melting the plastic mold but still set the PDMS. The microwells are then dipped into the residual PDMS and fitted into each port to ensure a tight fit. In the setup shown, the incubator is powered by an Arduino-controlled relay, using temperature sensor readings and a target temperature of 37 degrees Celsius to toggle the power to the coils on or off. As the thermal camera footage shows, the heating is relatively quick and even from well to well. However, the thermal camera showed that the temperature at the center of the wells was predictably higher than what the probe was reading, by about 6 to 10 degrees Celsius on average. A test was performed where the probe was submerged at various depths in a stirred water bath of known temperature, and it was shown that this variation was a result of the partial submersion of the temperature probe in the water. As a result, a promising alternative feedback system utilizing thermochromic blue-dyed PDMS and saturation analysis was considered. The dye changes blue to white at around 31 to 40 degrees Celsius. The temperature of the blue PDMS can be estimated by green light reflectance, as this has a smooth curve over this range, and can be further refined in measurement with a steeper trend in red light. Using a correlation based off these trends and a program to control the power to the incubator, a phone camera could be used to automate the incubation step in order to keep in line with the theme of a mobile-based system. Testing of the blue PDMS proved to be successful at both visualizing the heating of the PDMS, as well as demonstrating the predicted color change over the target temperature range. It's interesting to note that the color change occurs mainly over the upper surface of the PDMS and the portions surrounding the microwells, meaning that an algorithm used to estimate the temperature of the fluid in the microwells from the aforementioned reflectance correlation could be fairly accurate simply by observing the upper surface, which is the surface exposed to the phone camera in the full mobile-based ELISA setup. I hope you enjoyed this project, and I hope you will remember this next time you find yourself running an EIA on a tight budget.